In this next example problem, we'll be analyzing this urban street segment, Dumfries Road, and we're going to start with the intersection that we have previously modeled under the signalized intersection example, which is this intersection. So what we plan to do in this problem, we will open that intersection file. We're gonna add a second intersection located to the west, so Four Seasons Drive. And once we have two intersections, we're gonna have one urban street segment. We are also going to add one access point, which will be this stop control T intersection, Talon Drive. And then we're gonna add all the required input for our analysis. So in order to get started, we need to go to our course folder. So you should have downloaded those files. And we're gonna open this file number 1, Van Buren Road. And once you have your first file over here, which is the example that we worked previously under signalized intersections, we want to add another intersection. You'll notice by default you only have one intersection here. We're gonna add a second by clicking the plus button. And you can choose to start to model another intersection from scratch. But in this case, we're gonna import an existing intersection file. So let's browse for our file. And now let's find our intersection number 2, Four Seasons Drive, and hit open. And then another intersection will be created. For this position to insert, so that relates to the position where the new intersection will be added. And that will be concurrent with the forward direction. So the original file has a forward direction westbound, which means if you select after, the new intersection will be added to the west of the existing intersection. Or if you select before, that will be the opposite of the forward direction. So it will be added to the east of my intersection. But after would be my choice here. So let's hit OK. And you'll notice now we have two intersections, and because of that, we also have one urban street segment, which will be the object of our analysis over here. Next, let's define our segment length. By default, any new segment that's added will have a length of 1,000 feet, but let's change this to 2,430 feet. Let's hit OK. Next, since we have two intersections and they are both coordinated, you'll notice the offset input is now enabled. So let's enter an offset of 10 seconds for Four Seasons Drive. And for Van Buren Road intersection, we'll have an offset of 116 seconds. Next, we want to add an access point. So let's proceed. And we want to add this access point, which will correspond to the T intersection in the middle of the segment. I'll give the instructions in a moment, but we want to add an access point, and we will enter all the 30 movements for all directions, including number of lanes, and that will be used primarily to determine if there's any delay added to the through movements due to 30 movements. Let's get back to software. Let's open the detailed input data page at the bottom here. You'll notice a new page will open with a series of new inputs. And if you scroll down a little bit, you'll see the access point window over here. We're gonna add a new access point. You see the inputs become enabled, and then we can start adding our volumes over here. So eastbound left 0, eastbound through 2,400 vehicles per hour, eastbound right 9. Then we have westbound left 15, westbound through 1,850, westbound right 0, northbound left 13, northbound right 127 vehicles per hour. There's no southbound approach here. Let's also enter the number of lanes. Number of lanes is important because turning movements can typically add more delay if you have less lanes. It's always a recommended approach to enter a name to identify your access point, but it's not strictly required. And let's also enter the location, which will be the distance along the corridor from the upstream intersection. So here I'm telling the software that this access point is located 1,330 feet from intersection number 1, which will be Van Buren Road. We're done with our access point. The next step in my analysis will be adding the cross-section data, because this will be used internally to compute my segment free flow speed. The first input here will be the width of the upstream intersection. That is required because the intersection is also counted as part of the segment length, and I have 150 feet for the westbound approach, 125 feet for the eastbound upstream intersection. Next, the segment length with restrictive median. And by restrictive median, we understand as a raised curve, and we have a raised curve for the entire segment. So I'm going to enter the entire length, 2,430, for both directions. The percentage of street with curve on the right-hand side, I have 0 on the westbound direction and 100 on the eastbound direction. I have 1 access point on the westbound direction, 2 access points on the eastbound direction. The mid-segment delay input is a manual input for any other sources of through delay that cannot be captured by the methodology. For example, if you have a mid-block pedestrian crossing, this cannot be accounted by the HCM, but if you can get an estimate of delay, you can enter that manually, and that will be incorporated into the equations and the calculations. Those 2 field speeds, you can disregard them because they will be computed internally, but if you have our own field measurements, you can enter the numbers here and they will overwrite any of the calculations. On-street parking, we have 0, so no parking on either side of the road. And the speed calibration factor is just a manual input. Whatever you enter here will be added to the calculated speeds. So it's primarily intended for calibration purposes. And with that, we are done with our data input. What we can do next, we can go to report and select the segment report. And here you'll see the standard report for my urban street segment, which has a summary of basic inputs, and you'll see the performance measures provided on each direction. Just keep in mind that those 2 directions, they are not fully independent. So even if you're interested in just one direction, make sure you model both, because what happens in one direction may affect the boundary intersection, which may affect what's going on in the opposite direction. When you start looking at the measures, you'll notice that base free flow speeds, running time, running speeds, they are not very different comparing westbound, eastbound. But we start noticing some differences when you get the through delay, which is the control delay of the through movement in the downstream intersection. So as you may recall from the Van Buren intersection, there is a high through delay, and that's been incorporated into the segment performance, which can be noticed when you look at the travel time for each direction. So in that case, the eastbound is significantly higher because of the added through delay. And that, of course, will reflect in a lower travel speed. And since travel speed is my service measure, you can also notice that the eastbound direction has a level of service D, while the westbound direction has a level of service A. So if you want to justify the differences, would be primarily because of the higher delay that is being experienced in the intersection. Okay. The segment method has also multimodal measures. The urban street segment is the most complete multimodal framework with pedestrian level of service, bicycle level of service, and also transit level of service. And at the bottom of the report, we also have the facility performance measures. Because it's a single segment, the numbers here will be exactly the same, but if you have multiple segments in a facility, then a facility-wide measurement will be provided here at the bottom. And with that, we're done with our urban street segment analysis example.